something really dumb.
All right. Howdy.
Howdy.
Thank you. What a great turnout. Thanks everyone for coming. Okay, so this is our annual Meet the ISENs event. I think we have something on the order of 40 to 50 faculty, and we have something on the order of, I think, 1,500 students. And so in 4 or even 5 or 6 years, or however long people are here, a lot of times there isn't a time to meet everybody in your department, and it's a great opportunity for us to rapid fire kind of introduce ourselves. So welcome. This is meant to be a very fast, almost frantic event. We are recording this, but this is meant to be for those who are local here, and then the recording is for those who miss it, right? Asking questions is all part of the fun. So welcome, here we are, all right. There we go. So, all right, good. So the purpose here, 3 minutes, each presenter will be given. I think we'll be not super cruel and cut them off like I said we would, but we'll have people prepared for to be on their toes. But you'll learn a little bit about who they are, so as people, not just as like the instructors and the ones who, just determine your fate. They're people too, we're people too. So what are our interests? What are our interests that brought us into the profession of industrial engineering, our personal interests that take us here? And then in particular, there are some faculty who are very research active and want more people to be involved in their research, those who are interested in going beyond the classwork. So to some extent, you'll hear today about here are some maybe opportunities for those of you who are looking to do some research can come and follow up with. Okay, well, we know who we are, industrial engineers, but I always like to just kind of start off with this logo here because industrial engineering is a very broad field and it's difficult to summarize in a t-shirt, but I do like the idea of industrial engineers being a betterment engineering. Anything we do, we're looking at ways to do it better, and the science of making things better, I think, is pretty universal across our field. But you'll see, wrong slide, but you'll see we have a lot of diversity in the focus areas that go into the classes you teach, the disciplines that we're researching. First introductions here. So my name is Tom Ferris, Dr. Ferris here, and along with Dr. Sagapuram, Dr. Dinakar Sagapuram in the back, and Abby Ventilla, we are the co-track coordinators for the engineering honors track of industrial and systems engineering. So we've actually been working together for several years on related things, and I think we have a really great cohesive triumvirate of leadership here. We have the largest ISEN engineering honors cohort that we've had in years, or ever actually, so we're pretty psyched about that. And a big part of engineering honors from the college to the department everywhere is the research aspect. So we tie that into some of this conversation here today. Dr. Nataimo is here, and he'll give some words here shortly. You'll also hear later today from Dr. Banerjee and Dr. Junis, who are our undergraduate and graduate coordinators. So you may, hopefully if you don't know them, you'll get a chance to see them several times. And then of course, I want to point out our awesome undergraduate advisory crew, which is broad enough that I don't have all their pictures on here, but this is the easy way to get questions answered about our degree, about our programs and classes you may be looking into. All right, keep going. So this is on my feet. So what is research? What does that mean? So you're here to learn the skills of an industrial and systems engineer, and you'll go out to practice them on the world. But those skills have been defined by somebody who wrote the textbook at some point had to say, hey, here's a new idea and let's figure it out. Let's put it, let's make a new science out of it. So that's what research is. It's finding answers to what we don't know yet. It's something that you don't have a textbook to teach yet. Okay, so it's it's an additional step on top of learning what somebody else already knew, is to learn something that nobody really knows yet, right? So we train in that. There's a method to it. It isn't as easy as saying, I'm interested in this. I mean, that helps, but there's more to it than just saying, I have an interesting topic that I'm going to Google, in my spare time. There's a formality to it that we can guide you through. So yes, that is what is research. Why is research maybe a good idea? Grad students, I don't mean to only say undergrads here, but typically the undergraduate is the first time you hear about, oh, I could do this, right? So to introduce the idea that, those of you who may be first year students, or early on in your career, or maybe you're in your last semester and you're like, hey, I'm just now discovering I could have this opportunity. It gives you something that you can point to when you're ready to go for jobs or your next step that's very unique. Your grade point is one thing, but the wholeness of your abilities to contribute somewhere, sometimes that speaks a lot more for it when you say, here's my unique research experience I can talk about. And for those who might be interested in graduate school, for those who get a taste of the research and they say, this is really interesting and I maybe want to do more of it, graduate school is the route that allows you to do more of that. Having some good experience at the undergrad level makes you look really good on applications for grad school. Okay. This is one of our distinguished alums. So Tyler Wiener here, he was an engineering honors student we worked with. The research he did as part of his engineering honors requirements, it was recognized as the best thesis in science and engineering at the university level. He got a whole lot of fanfare for that. And we published a paper in a major journal from that work too. So that was some pretty deep science that came together in through the undergraduate research that you might do here. Okay, so what would you do if you wanted to participate in this sort of an activity? So first of all, I want to make it clear that it might say engineering honors requirements here, but I want to make it clear this isn't something that's an exclusive to one group. This is any industrial and systems engineering student is encouraged to explore your interest in these directions. Engineering honor students, you're required to explore that interest, right? So step one, you're going to learn a little bit about what people are interested in today. You'll also learn from your classes. You'll absorb this over time. There is an expected and appreciated time when a faculty is done with a class and a student comes up afterward and says, I heard about this thing you were doing in your research lab, or maybe you talked about it in class. I'd love to maybe be involved in that somehow. Maybe there's something I could volunteer to help with. So it starts with a conversation and an expression of interest there. You can catch them after class, as I mentioned, maybe not everybody. For me, that's okay. Office hours is a great time to say, hey, can we just chat about research? Because maybe I got to go and I got a whole bunch of things I got to get done today, but office hours, at least for me, is yes, let's come and talk about anything that you might want to talk about. Research, certainly within my realm of conversations there. A lot of faculty have lab meetings, regular lab meetings. I usually do with my group. And so if you say, hey, I'm interested in hearing what's going on, really easy for me to invite you to come be a fly on the wall or be as active as you can be, in lab discussions. I know that's the general attitude for most of the faculty here. So saying I want to do something and being willing to, you may have to, show your worth a little bit. So I always say, to some extent, you're going to want to assume you're going in and doing some voluntary sorts of stuff. To some extent, this is learn about what's going on in here so you really can be, have a skill set that you can work with here. But then there are mechanisms to make it, to make it a formal sort of arrangement, either through credit hours, and ISEN 491 is our credit hours that you can take. It must be done in coordination with the faculty, and we have specific rules for that. So we can talk about that when we're not on our feet here. But in any case, there's a step where you kind of ease in here. The research hours, we have now every 1 credit of research hour that you register for. Think of this as 5 to 6 hours a week. This is like a lab class. So this is our current policy. So to be thinking about, well, how much can I do in this semester if I'm also taking, 15 credit hours of classes, that starts to be a consideration. When you talk to the faculty, when you talk to the advisors, they're pretty good at advising through that sort of thing as well. And you can't just say, hey, I'm going to go and work with this faculty if that faculty doesn't know you're doing that. So make sure you have this kind of worked out ahead of time. And then you conduct the research, and up to 6 credits of this course, 491, can count towards technical electives on your degree. So we have awesome technical electives that I don't want to, steer you away from, but this is an option for those who are really, dedicated to a research sort of project here. Engineering honor students in ISEN, 6 credits is required. So think of the scope of your work. This is also something we will talk about with specifically the engineering honor students in one-on-one meetings that we'll always have. And we'll talk about, well, there are ways to plan this out over, several years that makes sense with whatever your schedule. So 6 credits doesn't mean I have to take 3 and 3. It could be I take, 1 or 2, depending on the scope of the work that you're doing, in a semester. I'm pointing out these pictures right here because this is an undergraduate student, Trey Rohde, who came to my office my first week here at Texas A&M, and he knocked on my door and said, I'm interested in research, and he is now Dr. Trey Rohde after sticking around and completing a full cycle of, he finished his PhD with us. So it was a fun introduction in the undergraduate world, and now he is a full-time researcher. You're going to hear today from faculty in 4 major ISEN focus areas, and I'm just going to rapidly show you the buzzwords here and let each person, each one, detail as they come. Advanced manufacturing is one of our major focus areas. Engineering data science, operations research, and health and human systems engineering. And I've asked each faculty when they introduce themselves to make sure they're talking about which focus area they come from. I've also got a key here so you can track. So if you think, hey, my manufacturing course is really, really awesome, I'd love to do more of this, you might, pay extra attention when we have those folks presenting here. And of course, systems engineering, let's not forget, is about interactions among things. And so how these all blend together, you don't have to distinctly define with one. It helps as a starting point, but realize that industrial engineering may be across several of these. Okay, we're about to get started here. So each presenter is going to get 3 minutes. We're going to kick this off with a student experience. And so what we'll ask is 3 minutes per presenter. We'll cut people off. Yeah. You should probably cut me off pretty soon. Yeah. We are on Zoom, and so if people want to join via Zoom, don't mess up the microphone situation, but you're welcome to enter questions via the chat box. And otherwise, yes, raise your hand. We can see each other here. This will be great. If you're here for engineering honors, this is a QR code to sign in. I've also got it on the next page. So, and this is the F'22 meet the ice text, yeah, you can see it, right? So that's the whatever event tag. And finally, okay, here's our schedule. So there I am, I just talked, and our next, get that out of the way. So here's our event sign in. So I'm very pleased then to introduce student researcher McLaren Wang, who's agreed to come and talk a little bit about his experience as a student researcher, right? Thanks, McLaren. Oh, yes. Oh, you need your slides. I'm an idiot. All right. That's the other thing. Okay, sorry. You're welcome. Yeah, we don't have time for this. Okay, this one, right? Yes, sir. Oh, yeah. Here, let's do it like. Am I messing it up? I believe like. Just within the Google. Okay. All right.
Howdy, my name is McLaren. I work under the advisory of Dr. Kabatnam. He's one of the big sharks in advanced manufacturing here, and it's so I'm here to talk to y'all a little bit about just what it's like to be involved in research in ISEN. So I'm Dr. Kabatnam is in the branch of advanced manufacturing, and what we do here is we try to actuate what you might have heard as Industry 4.0, or some say we're transitioning to 5.0, and it's mostly this sense of we figured out a lot of mechanics, we figured out a lot of electrical, we've even introduced computers. How do we glue these things together, and how do we take the whole picture into a further degree of development? So here's a decent illustration of what it's like to actually do what we call smart manufacturing. And a couple of highlights here is 3D printing. This is what became exceptionally popular in the last 10 to 15 years, if you will. We do a lot of that. We do a lot of the IT part of this because actually this relates to one of our projects, which is how to set up the peripherals of, let's say, a online 3D printing workshop where people can access from various parts of the country or even internationally. How do you set up the technology peripherals of it? We play with intelligent control, machine learning. We apply machine learning to a lot of our projects, especially CNN for picture recognitions. We do cybersecurity, though cybersecurity does have its portion in manufacturing, especially with what we call smart manufacturing. It's you have a lot of telemetry, if you will, and so cybersecurity can certainly be very helpful in helping regulating and developing some of that. On top of that, there's always a huge demand for new materials or novel materials and methods of processing materials. So here's a few examples of our projects. This one, we have one of these machines here in DTB, and this is what you call a hybrid machine. A hybrid machine meaning it integrates milling and lathing, the subtractive part along with the additive part. So we do that currently. I'm actually involved in a project that utilizes this machine. Something else we do is this is what I call the cybersecurity within manufacturing. So imagine in a situation where an attacker seeks to interrupt your system, your loop, if you will. How do you provide check and balances for that? Well, we introduce what we call a watermarking, which is we introduce a fuzzy but controlled variation of the feedback signals, and that's how we can think of it like an encryption, if you will. So there's a lot of research into that. This smart printers. Oh yeah. A lot of printers today have cameras, but how do you go a little further than that? How do you let's say introduce more robust controls, remote controls, if you will, into your printer, so you can control it in a remote setting. People can access it from anywhere within the country. So
That's do a closing remark. Okay.
Thanks,
Thank you.
McLaren. Thank you so much. Awesome. So that's very complex work, and I missed McLaren. What year are you? And you're
I'm here at 2024.
okay, great. So you're
Junior.
you're a junior. Fantastic. Good. Yes. Excellent. Thank you very much.
Thank you.
So our next contestant is the
Yeah.
infamous. Oops. Hang on.
Yes.
Sorry, I didn't think about that. It's lame to. Well, maybe we can show it from here. Good. Download it that way.
Howdy,
Howdy.
I'm excited to be here. Let me introduce Dr. Will Wilhelm. He's here. I think some of you may not know him. He's Professor Emeritus. He was with the department for many, many years. When I started here in 2004, he was a full professor teaching in the department. You want to say a few words to the students? Will?
Well, I've been retired for quite a long time now, since 8 years. I never expected to live this long. But I came today. I haven't been in the office for. I came today because I've been wondering the department's grown a lot since I retired, and I don't know if I want to try to figure out if I holding the department back. And all this many new people.
Thank you, Will. Thank you. And we appreciate you coming. And students, he's here because he wants to listen, to you and see what's going on. As a department, we have grown. Last year, we had 938 undergraduate students. This year, we are around 962. Our graduate program has grown by about 70%. We had 362 students last year, and now we have 612. So overall, as a department, we are doing very well, over 1,500 students. So it's awesome. And the great news is we've been ranked number 9 at the undergraduate level for the last few years. And this year we have gone up. So we are now ranked number 8. So we are in the top 10. Our vision is to be in the top 5 in the nation in the next 5 years. That's our goal. And our number 1 goal as a department is about students. So we want to recruit, retain, and train the best students. And so we are always excited when we see students who are interested in research. And that's why I appreciate what the coordinators are doing, helping us with doing this. So briefly about myself, I've been with the department for about 18 years now. And I'm in the operations research area. I do teach different courses, and these are some of the courses that I have taught in the department. Facilities planning, material handling, systems thinking, operations research, one for undergrads, nonlinear programming, and also I teach large-scale stochastic optimization. In terms of my research area, I deal with problems involving decision-making under uncertainty. That's where my passion lies. With lots of applications. Right now, I'm developing new models and algorithms. But I like to talk about applications, and so I have a few applications I will talk about today in healthcare and also in power systems and wildfire management. Yeah, well, now just about my personal things. I have 4 kids. I have 4 children. My oldest son is at MIT. He's doing mechanical engineering. And my other child is here at A&M in statistics. And the other 2 are in high school. One is in high school, one is at home, okay? I love traveling. I haven't traveled since COVID, but I think things are opening up. Maybe I'll be able to travel more. I play soccer. If you play soccer, then you can do research with me. Yeah, we have several faculty members who play soccer. So if you want to join us, that would be great. I do something very unique that not many people do actually. I have bees at home. So I have a couple of beehives. Anybody
I love
familiar
that.
with bees?
That's yeah.
Awesome. Maybe we can talk. So I have honey too. If you want honey, I can give you some. Okay. So those are some of the things I do. So quickly, I have 1 more minute left or 2 minutes. 2. So I'm doing work in healthcare with CAPS, the Counseling and Psychological Services at Texas A&M. They reached out to me in 2020. They said they were having a lot of issues with students having mental issues, and there are a lot of students there, they couldn't manage their schedules. And so they reached out to see if we can help them. So I'm working with Dr. Afrahimian on improving their scheduling of students, scheduling of the counselors there that they have. They have about 32 counselors, so it's a limited facility, but they have thousands and thousands of students who go there. So we are developing simulation models, queuing models, and also we've developed some stochastic models for them. When COVID started, I became curious as to how they decide, how many people should be vaccinated and so on. And so I've done some work which has been published now. on optimal vaccine allocation and uncertainty. How do you decide how many people to vaccinate in a given county in the different age groups in order to prevent an epidemic? So that's kind of the typical problem. So I worked on this problem a long time ago, 2008, for influenza. And when COVID started, I went back to epidemiology models. So I love that as well. And then another area that I'm actively working on is in emergency response planning for wildfires. As you've seen, climate has changed. Some of you don't believe in climate change, I do. And so there's been a lot of large scale wildfires happening. The question is, how do you plan to minimize these wildfires? So one way is to prevent them in the first place. We call this fuel treatment planning. How do you change the vegetation and landscape to prevent large scale wildfires? And if the fires happen, how do you fight them? That is emergency response planning. So I've been doing some work. This is a funded project with National Science Foundation. We are in the second year now. In fact, I've had undergraduate students work with me on this project. Caitlin and Kaylee. Kaylee graduated. And now I have Caitlin working with me this semester. I'll be looking for one more student next semester if you're interested in working on this kind of work. And then lastly, I'm also working on wildfires, but with folks in power systems. In California, some of the wildfires were ignited by electric power lines. And so how do you manage the transmission, the amount of power you're transmitting when the weather is bad to prevent ignitions of wildfires? So these are a few things that I'm working on. Thank you.
Thank you, Dr. Yatayama. Okay, hang on one sec while I got introduce our next distinguished guest is Dr. Farzan Sasangohar. Dr. S, if you could give me a split second to load the files, I finally got them configured here.
By the way, we have some snacks.
Yes. Get some snacks.
The audio is that it's
Yeah.
supposed to be, yeah. Is this Abby, do you know why it's not going through? Anyway, I was trying to share my screen with this. Anyway, who knows? Because this one has to stop it.
Yeah, stop.
There we go. That's what it is. That's what it is. Okay, cool. So there's our schedule. Sorry. And then I was going to use this screen. That's silly.
Yeah, you can't just leave that up.
Is it making us sign anything? I better get out of here.
Okay, yeah, now share it again. Share the screen.
Good news is we want.
Luckily, we don't have
This anymore,
anybody
right?
on Zoom, so
Okay, just one person.
this.
The Applied Cognitive Ergonomics Lab is a multidisciplinary research lab that focuses on human-centered design, development, and testing of user interface systems. We ensure that human cognitive and physical limitations are considered when planning artificial intelligence-based interventions for healthcare, aviation, and process control systems.
Just surprised me. All right. Good morning. My name is Dr. Sasangohar. My students like to call me Dr. S for short. So I'm a difficult one. I lead a lab called Applied Cognitive Economics Lab. It's in the group called Health and Human Systems Engineering. In fact, my field of expertise in what I teach is mostly in healthcare human factors, healthcare systems engineering. In our lab, we do a lot of projects that are very applied. They're in close collaboration with hospitals, with healthcare systems. And the focus is nowadays a lot towards telehealth and remote patient monitoring type of technology, especially in underserved communities, in vulnerable populations, like college students, combat veterans. So it's kind of focus of lab these days. But I'm going to talk about 3 buckets of research just to get you exposed a little bit to kinds of things we do in ACE Lab. And by the way, I teach ISEN 330. If you haven't taken it, hopefully I see some will be in ISEN 330. I offer it in Greece this summer.
Oh,
So if you
Mhm.
want to know more about it, talk to Nicole because she took it last summer in Greece. And she's also in one of these projects I'm going to talk about. Or what? So first bucket is remote health monitoring. Why is that important? Because people are not necessarily having equitable access to care, right? So you have underserved communities, which may not have the same access as an urban environment to get healthcare. So that's necessitates need for self-care and remote monitoring. So providers need access to data from patients, from the comfort of their home. So that creates this opportunity to create these technologies to help people take care of themselves and also give some meaningful data to providers. So we worked on several categories of remote patient monitoring technologies. Most important one is mental health. So I have a line of research on mental health monitoring, self-monitoring, and remote monitoring for college students, for combat veterans, for PTSD, for example, for nurses in ICU, for example, who are experiencing a lot of burnouts and they need to be monitored. And these technologies are a combination of telehealth, mobile health application, body-worn sensors or rest-worn sensors. So the kinds of things you learn by doing these projects are, and you can choose which one you're interested in, are design and development of intuitive human-computer interaction, a lot of AI, machine learning, data analysis. We're getting a lot of time series data from these sensors, either on the wrist or body, heart rate sensors, accelerometer sensors, blood pressure or blood pulse volume type of sensors. But that needs to be analyzed and made sense of, and then fed into some sort of detection mechanism that, learns something interesting about you continuously and real time. And that's the future of healthcare. But people are very these self-management, remote monitoring technologies, and not only they take care of themselves, but also there's now a lot of data, good data on the provider side, so they can make assessment better. So we do that for mental health, and Nicole can also tell you a bit, about that because she was with us this summer, working on mHealth, which is our college student mental health application. She worked on similar concept for different kinds of conditions like hypertension. This is high blood pressure, killing a lot of people. Like hypertension, diabetes, these two combined, are killing a lot of Americans. And these are the types that could be self-managed and monitored remotely. So we have applications for self-management and remote monitoring of hypertension and diabetes. We also have a lot of other systems that are more focused towards these vulnerable populations like underserved rural areas, like South Texas, like East Houston, like Miami-Dade. And I'm involved in a big intercept project called PATS Up. The goal is to design these revolutionary technologies that help people monitor themselves. With diabetes patients, it's just an injectable sensor under the skin. You can take care of yourself, even if you don't have access for longer amounts of time. So that project is huge. Our portion of it is to understand requirements for these tools, human factors, kind of go into these communities, understand what they need, what are the expectations, and then inform the design of these interactions. These are not your typical interactions. We're talking about 10 years from now, you're taking care of you, without a provider involved. So you have a sensor in you, you have all sorts of lap in the palm idea, lap in the pocket idea, so you can take care of yourself. These are new ways of interacting that need to be designed. That's human factors. And the last bucket of stuff I do is pure systems engineering. I'm a systems engineer by training. That's most of my graduate training. And I love, complex systems. I love to understand them. I love to model them. Things like integration, things like adoption, things like usage, behaviors, and all these stuff. It's not just the technology itself. You have to pick it up, use it, and use it sustainably. And a lot of these are systems engineering things we need to understand. Resilience, team decision making. So I have a line of projects that deal with, systems engineering concepts in military command and control. We have a test bed in our lab that does military command and control and supporting supervisors in those domains. And we do a lot of work with emergency response systems, which we do have, by the way, the best in business. TEECs, our facilities in the disaster cities, kind of a world known for doing these kinds of things. So we do work with them to understand these complex systems. Thank you very much. I hope to see some of you in my research courses. Thank you.
Thanks, Dr. Ed. I'm really sorry for dancing around. I was trying to
Trying to move that.
bar.
We
The
did it
internet
earlier.
killed it. Get rid of
Don't
this.
you know how to move that?
I'm not sure you can.
Click the, well, we did earlier. First person.
Oh,
Click the chat.
Yeah.
There we go. Put it,
Oh,
well,
okay, all right, so because there was a chat, all right, so I keep messing it up. I was gonna put that thing in the chat. What I did put in the chat was the schedule, which we are slightly behind on, so let me please introduce Dr. Bukapatnam. Valley up here.
Let's see if I can help or mark this.
Just have one long PowerPoint.
'cause we didn't have it.
Yeah,
Thank you.
yeah, hopefully, I probably don't have to speak much because McLaren did a marvelous job of introducing what we do in the lab. Thanks, McLaren. As he mentioned, our lab mostly focuses on the area of smart manufacturing. At the outset, the classes I teach, as well as research I do, are at the intersection of manufacturing and data science and AI. So if you look at what's happening in the real world, the factories that we know are basically getting transformed into basically data intensive operations. Essentially, data is getting highly pervasive across factories. So whether you are interested in manufacturing or data science, you need to know both, because manufacturing is basically how we kind of make things, and data science is basically how we analyze and make things better. Right? And the classes we teach, I mean, at least I teach here, involve both the fronts. I teach 281 from manufacturing at the undergrad, as well as 689 course in smart manufacturing at the grad level. And I also teach 413, 613, 614, all different kinds of data-driven courses for the data science program. And in terms of research, we have multiple sponsored projects with various government agencies as well as the industry, all in this area of smart manufacturing. Let me talk about a couple so that it gives a glimpse of what we do in the lab. First one is a project with Lawrence Livermore. It's one of the Department of Energy labs. What they're interested in is to create a new energy. So they want to create fusion energy. So basically they want to get rid of all the dangerous uranium and other kinds of things, so create a cleanest form of energy through hydrogen. So the way they would do it is they bombard the small pill that contains some chemical with very high energy radiation, and that would release the energy needed for all the nuclear fusion reactions. And to create that pill, they have to create a highly precise component. That's where industrial engineers come. The skills that we have is the ability to make things and also make things perfectly to assure quality. So again, all credit goes to our students. They actually put together a system where they can design a process for making these pucks, or basically these shells. And also they actually create a smart setup where they are looking at the data while that particular part is being made to make sure it meets the quality. So the kinds of work that we do is, I mean, not just exciting in the sense that people with interest in hands-on, they can get involved. And also people who have a highly analytical bent of mind, they can actually get involved in analyzing the data from there. But also it would be highly impactful because as a result of their work, Lawrence Livermore was able to show that they were able to enhance the yield of the nuclear fusion by an order of magnitude. I think that was a good, and also we have looked at other projects with the industry and National Science Foundation. Interested, I would be glad to talk to you. And also in terms of research, I want to share one point. Teaching is basically about learning what exists. Research is about contributing to the knowledge. And what got me into academics was this balance of the ability to share what I know and also enhance what people know. So in other words, what we do in the lab is to contribute to the knowledge of manufacturing processes, create some innovative processes, or understand what happens in the process. And also, similarly for the data science, we just don't use the existing machine learning methods, but our lab actually engages in developing newer methods that really go on and address the problem. So essentially, it's a problem-driven research in manufacturing and data science. That's smart manufacturing. And in terms of data, we probably have only the largest amount of data collected in the manufacturing domain. So if anybody is interested in data, we have all the data for you to try out and then work with your different kinds of techniques that you may have learned in 413 and other classes and beyond. And we can use it for quality assurance, cybersecurity, as well as, and also creating newer kinds of materials and so on. So this is the kind of things that we engage in. And pretty much every project that I have worked on that forms my current portfolio pretty much addresses some of the real world problems by combining advances in data science and manufacturing. And I hope I introduced what I do for our research. And if you have any questions, of course, you can talk to me, or even better, talk to McClure.
Thank you, Dr. I thought I saw, is Dr. Ekman here? I thought I saw, maybe stepped out for a minute. So we're going to try to, here's a quick, oops, all right. We are on, we're a little off schedule. So what we're going to do is Dr. Sagapuram and I are here all day. So we'll fit ourselves in between things here. So I've asked Dr. Zahabi if she could give her spiel. This will be a perfect blend coming from Dr. Bukapatnam's work. We'll hear about a different focus area. By the way, so I'm going to update this schedule at the end of today, and then you can go back and use it as a resource to see, okay, who is in which focus area. We'll also have this as an online video, so you can go back and review. All right, thank you, Dr. Zahabi. You may jump in here. Thank you.
Thank you. Howdy.
Howdy.
I'm Mariam Zahabi. I'm assistant professor in this department in the group of health and human systems. My teaching courses, you can see here, I teach 210 and 330. And then my research is mainly in human machine interaction and with applications in surface transportation and assistive technologies. And I also do a lot of human performance modeling. So I'm going to jump to some of the research projects that we do in our lab. And so I want to start from the left one. So this is a project funded by the National Science Foundation. And our target is law enforcement officers. So we are trying to provide adaptive systems for them. The systems can understand their cognitive workload level, and based on their mental workload, they can adapt vehicle technologies for them. So we are now in actually the second year of this project. In the first year, what we did was we went through different departments and we did a lot of ride-alongs with police officers to understand what are the situations that they are going through, what are the workload levels that they are experiencing. And from these observations, we now have a database that tells us about the physiological measures of these people, about their cognitive workload level, what activity they were doing. And then my students and I are working on creating machine learning algorithms to predict their workload based on these responses. So we hope that in the second phase of this project, we can provide adaptive systems that can, for example, change to high clutter or low clutter based on the level of cognitive workload. Because at this point, what they have in the vehicle, they don't have any adaptive system. It's just there. A company provides this system, let's say mobile computer terminal to them. It doesn't understand the human at all. So at some point, for example, they're going through the pursuit situations or high demand situations, they cannot use these technologies at all. And we have seen a lot of crashes as a result of distraction, as a result of high workload for these officers. So our goal is to improve their safety by providing these adaptive systems. Okay? And in the second project, again, this one is also funded by National Science Foundation. We're working with individuals with disabilities and older adults. So a lot of older adults and individuals with disabilities, they have problem navigating indoor environment because a lot of applications that they have is only for outdoor, and there's no accessibility for the apps that are designed for indoor navigation. So we are working with departments, including computer science and electrical engineering, to design an application that is accessible for these individuals. We have done user testing with them. We have done focus group with them to understand what they need and what they want to see in these apps. And from these feedbacks that we got from people with cognitive impairment, physical impairment, people who have visual impairment, we now understand how these systems should be designed. We have designed a preliminary sketch of these indoor navigation apps. So the next step for us is to implement it. So we are trying to use beacons in different part of the building, not actually this building, with my collaborators of electrical engineering. So we are trying to put these beacons in order to implement it and then have actual user test these interfaces and these apps. So we can see if they can successfully go through, let's say, an in-vehicle and in indoor navigation system using the app that we developed. And then the last one is another project, again, for people with disabilities, but this time we are working with people who have upper limb amputations. So this year is actually the last year of this project, so we have made a lot of progress since the beginning. So this project was designing how to design prosthetic devices to reduce the mental workload for people with upper limb amputation. A lot of people think that when you use prosthetic devices, the main issue is the physical comfort. The physical comfort is important, but mental comfort is also important. So in our lab, we designed a usability assessment tool. How can we assess these systems in advance in the design cycle so that these products are easy to use, they're reducing mental workload. We have also put together an algorithm to predict, again, the cognitive workload of these patients when they're using these devices. And then you can see on the top, there's a virtual reality-based simulation. So we designed a virtual reality simulation. Instead of doing an actual experiment, they can just wear the goggles and experiment using 2 EMG sensors, and even without the hand, they can just use the EMG sensors to move some of the let's say, control the clothespin for the task, and they can experience how would this prosthetic device respond to their EMG sensors even without the device. So that's an easier tool for them to mentally be prepared for using these devices. Okay? So if you're interested in any of these projects, we also have one more with DARPA and another project, again, with National Science Foundation. But if you're interested in something related to this, please contact me. I would love to have undergraduate students in my lab. I do have a lot of undergraduates working with my PhD students. Yeah, I hope that this provides you good information on what we're doing in our lab. Thank you.
Thank you, Dr. Sahabi. Thanks so much. Okay, who do we have? Dr. Ekman? Okay, Dr. Sakapuram, would you like to come next? Thank you very much. Oh, it's on the share drive. All right, perfect. Thank you.
Hey, hello everyone. My name is Dinakar Sagapuram. I joined the department in 2016, so I've been here for some time now. So that is me, how I look in the department when I'm here, but that is me when I'm at home. That's my wife and 4 kids. There is one there that's hard to see, that's Annie. So I'm in the advanced manufacturing track in the department. I'm an assistant professor here, and I teach courses in the manufacturing area. At the undergraduate level, I teach ISEN 281. That's the introductory manufacturing class. And in the past, I have also taught ISEN 370 production systems engineering. And I also teach a grad level course in manufacturing processes. So in terms of research, by training, I'm a material scientist. So our lab is interested in understanding how materials behave more fundamentally. And we do it in a manufacturing context. Okay, so when you think about manufacturing processes, we basically torture materials, right? We cut them, deform them, melt them, and so on. So our group is interested in developing new experimental techniques and also models in predicting the material behavior, how to make processes better, as well as how do we develop new materials with that type of understanding. Our specialty is in machining-based processes. Again, you might have taken courses probably in 281 or MMET 181 about CNC machining type of things. You probably would have learned things about deformation process. So we work in that domain, and we are broadly interested in two things. One is in understanding how materials deform and fail, because that is one of the main process limitations in these applications. And equally importantly, we want to understand the friction. Okay, so this is a topic of special interest to our group. How do we model friction? How do we quantify that? And how do we mitigate friction so that we can enhance this process, make them more energy efficient, because we have a lot of frictional losses in all these manufacturing processes. And another specialty area for our group is in developing new experimental techniques. We work with a lot of high-speed imaging techniques. Think about visualizing material phenomena at about 1 millionth of a second. So very super high speed. We develop new sensors as well as cameras to capture fundamental material phenomena and then develop models based on that. So how can you get engaged with my lab? The best way to do that is send me an email if you're interested in these type of topics. Very easy to remember, just my first name at tamu.edu. So you can see some of the pictures here. These are all undergraduate projects, students who have worked in the lab or as part of the courses that I teach. Primarily in the area of either prototyping or building things. Think about either on the electronic side or CNC machining, 3D printing, building new fixtures, developing new experimental techniques. And the other area is in on the imaging side, making some cool measurements at very high speeds and so on and so forth. So if you're a little bit more inclined on the mechanics, materials, physics during your high school days and want to understand a little bit more about how can you apply those concepts in an advanced manufacturing setting, our lab, I think you'll like the work we are doing here. So I think that is all I have, and happy to answer any questions. Again, feel free to reach out to me. And I'm also one of the coordinators. So if you need any help in reaching out to other faculty members, trying to understand how can you get engaged with different focus areas, you can also contact me. I can facilitate some conversations with the faculty members and go from there. Okay, thank you for your time, and look forward to seeing you, at least some of you, in my labs.
All right. Thank you, Dr. Sakapuram. All right. Up next, Dr. Ekman. Yes, thank you. And if I'm remembering correctly, I think Dr. Ekman is the first representative of the data science group.
Yeah, maybe.
I believe you are. Thank you. Okay, all yours. Thank you. Oh, yep.
Okay, no microphone. Good.
Oh, this is the
Hi
mic.
there.
Yep, you're all set.
Hi, everyone. I'm Dr. David Ekman. I'm in my second year here in the department. Like Dr. Paris was saying, I'm on the boundary here of the data science and operations research groups in the department. Courses I taught 413 last semester, so that's a senior tech elective for advanced data analytics, machine learning there. And this spring coming up, we'll be teaching 355 system simulation, also an honors section of that. So if you're interested in learning a bit more than what would be in the typical class, let me know and we can maybe get you into that section. On the research side, I am in the area of simulation optimization. So if you've taken 355 already, what I work on is the algorithms that allow us to solve problems with those simulation models that we built. So not just the what if analysis, but what is the best decision to make, having used the stochastic models. So I do a mix of decision making on uncertainty, some analysis methodology for how do you analyze simulation inputs and outputs for decision making, So that means it's a mix of probability statistics for me, stochastic processes, optimization, and computer programming. So I would say if you like maybe at least 3 out of those 4, you might consider research in this area. Oh, I guess I have some personal things. In terms of pictures here, that's me with Reveille. Not to be outdone, I have a dog myself who likes to lay around under TV tray tables for most of the day or other furniture. I'm married there. I have a newborn at home right now. So if I look tired, that's why. And in terms of hobbies, I like to bake a lot. So that might be cake, cookies, bars. Been baking a lot of scones recently. With cake rolls, these kinds of things. Yeah, I should bring them into the office.
Now.
In terms of research, for undergrad research, looking for assistance in coding simulation models and optimization algorithms in Python. So last spring, I had a group of undergraduate students and also this summer who were helping contribute to SimOpt. It's an open source Python library I've been developing for simulation optimization problems and solvers. So if you have taken 355, imagine those models you built in Simio, it's building them in Python now. Some object-oriented programming involved, coding these models and helping to understand them. So like I said, it's all of that. Probability statistics, your OR1, OR2 classes, and computer programming in the mix. So I look for help on that. If you are interested, you can email me. It's my last name @tamu.edu.
Thank you, Dr.
Thank you so much.
Okay, so Dr. Banerjee, if you are ready, we've adjusted and we're back on track. So thank you. Thank you. Dr. B. Yeah, that's the mic.
All right, good morning. My name is Dr. Andy Banerjee, and I've been here quite a while now. And my area of expertise is in modeling and simulation. And I primarily work in the area of data science, and I'm also leading the effort in launching the data engineering program that some of you may have heard about. I've taught a good number of our undergraduate and graduate courses. You can see the list there, 210, 355. I've also offered the elective 425 a few times in the past, 405. I was teaching those last year. And a couple of graduate level courses in the recent past. One is 625, which is the simulation course for the graduate students, and 650, which is on the healthcare side of things. So those are some of the courses that I'm involved with. I also serve as the associate head for undergraduate affairs, so I've probably seen some of you. And again, if there are any questions about the undergraduate program, things where I can help, definitely come and talk to me, reach out to us, the advisors also. And in terms of the research, and I'm mainly working on modeling and simulation and applications in a bunch of areas like manufacturing, healthcare, information, energy, and other interesting problems as they come along. So that's kind of what I've been working over the years, and still working in these areas. In terms of my hobbies, I like to travel. I've visited many places here in the US as well as overseas, many countries. So that's something that I like, and my family. I also enjoy college sports. So especially some of these March Madness, football playoffs and other things. Those are things that are of interest to me. And I also like some of the late night comedy shows as well as some British comedies. Those are things that I enjoy watching. In terms of research, again, you can reach out to me. I work on a number of areas, but I just wanted to highlight a couple of things which might be of interest to undergraduates. And I have worked with some undergraduate students in the past on different types of problems. The one that I'm currently involved in, we had 2 students this past summer, 1 student currently working in this fall semester, and we had a couple of other students summer of 21. So this is on Industry 4.0 and many, I mean, it's a concept that's out there, but there are many moving parts to it. So for instance, looking at sensors, sensor placement, collecting data from there, how do you do data fusion, Internet of Things, how do you have these sensors talk to each other? And with the ultimate goal of actually having it for better decision making. So we have some of these devices on the third floor of this building, and this basically serves as a training kit for Industry 4.0. So it's like a small tabletop manufacturing setup that we have, where it is already has a bunch of sensors in there, but we are also working on placing additional sensors. So these are research questions. Where do you place sensors? What type of sensor do you need? How do you collect the data? How do you synthesize the data and collect and get meaningful information from it? So those are the type of problems the students are working on in terms of looking at Industry 4.0 type of problems. Also, I have a lot of background as well as interest in looking at multidimensional data. And these are some examples that I'm showing here. One of them is a work that I did with the Texas Guardianship Association, where they look at guardianship cases that are going on across all the 254 counties in the state. And they asked us to work on and see how these cases are being developed and what kind of resources they will be needing and so on. So it's kind of a data analytics project that I did with one of our students in the past. And then the one that you see on the bottom right is a project that I worked with Dr. Abrahamyan and a couple of students. And this is again looking at hospital data in terms of care that was provided. And these are rural communities. And providing care is expensive. There are resources and I mean, for instance, surgeons, specialists, as well as medical equipment that's very expensive. So how do you have some kind of a sharing arrangement for these rural areas where it makes sense to actually collectively purchase some equipment, collectively have specialists and a resource sharing agreement? And how would you look at distances, and if something closes down or if we remove a service, how does it affect the quality of care in those communities? So those are type of, again, data analytics project that we were interested in, and we followed up and some results that we had to show. And this was sponsored by Blue Cross Blue Shield. They were interested in providing rural healthcare and all that. So these are, this is a glimpse of the type of projects I'm currently doing, but there are several other things also that that I'm working on. So it gives you a flavor of the type of projects I'm interested in. Once again, if you want to talk to me, feel free to get in touch with me. I'll be happy to discuss some of those. So that's what I have today.
Thank you, Dr. Banerjee.
Thank you.
Yes. So we're doing all right with our pace here. So Dr. Junis, you're just on time. If you would like to say a few things, I don't know if you have any slides. Okay, well, that makes things a little easier for me then. But you can have the floor. That's a microphone, so in this.
We're recording it.
Yep.
You're recording.
We are recording.
That's a mic.
That's a mic.
Right,
That's
sure
our new
is.
mic, you know, there's issues in here.
Well, howdy.
Howdy.
I'm supposed to say, that wasn't good enough.
Howdy.
Learned, that's what I've learned. Yeah, I'm sorry, I don't have any visuals, but my name is Joe Junis, and I'm a professor in the operations research area. And I also teach a course sometimes, ISEN 370, because I apply operations research to supply chain planning problems, production planning, inventory control, and really exciting sounding things like that. And so I've worked on a number of different types of problems involving anything from where to locate things, so facility location problems, and train routing, how to move trains around between stations. It's actually interesting problem. And generally these problems where you have, let's say, a manufacturer who wants to produce and sell something and sell it to a bunch of different markets, and then you have retailers that they sell it to first, who then resell it to customers like yourself. And they have lots of challenges in terms of how to coordinate product flows, where to make what and when to ship it to the different retail stores, how to get it there most efficiently, and how to split the gains between the retailer and the manufacturer, who are actually, even though they're cooperating with each other, are also competing for the customer's money in terms of how it's split between the manufacturer and the retailer. And that leads to some really interesting problems on how to best coordinate and also determine who gets what in terms of the profit, how to split. But I generally like interesting problems, operations research problems. So my first love was really, first love was really in programming. In a sense. I don't want my wife to hear me say this. But that really got me excited about the possibilities and the sort of theory and math behind it. And so I wanted to sort of do that. And I'm not as courageous as, say, Dr. Moreno, in the sense that if you want to do that, you have to be really, really smart, you know. And so I had to find somewhere to apply it. And the supply chain production planning area is a great place to find application of really difficult problems that you can solve, right? And also, excuse me, have some sort of impact. And I guess when I was an MBA student, I heard this professor talk about a problem he had solved for a digital equipment company who was a computer manufacturer. And they source their parts from all over the world. And you can imagine how many parts a computer has, and how also an automobile, for example, how they all have to get made at different places. They have to come together and be assembled and then shipped from factories all over the world to our ports. And how do you decide, you know, what happens when, how to do this all most efficiently? It's very challenging, but you can use these tools of linear and integer programming to solve these problems, or at least get close to the best solutions in acceptable computing times. And I found that fascinating, that was possible, because there's just too many factors for the human brain to think about, yet we can come up with ways to solve these problems using computers. And so that's my 5 minutes.
Thank you, Dr. Junis. Yep, all right. Next presenter, Dr. Tuo. Thank you so much. I skipped myself in the schedule, and I'm going to do the shortest, most compressed version at the very end. So, oops, wait, I don't have it here. Is it on the shared drive? Sorry. Oops, I don't have it. Oh.
I guess I'll.
Do you see it? I don't see it. Yeah, of course. Sorry. Yep. Thanks.
All right, it's Friday.
Howdy.
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 You want me to download and display it, or
Share screen.
does that do it? What am I doing?
Yeah, top left, it's view.
Oh, this? Oh,
Or that.
thanks.
Wait, we gotta share the screen now.
I have to share the screen. I'm so
Yeah.
sorry. Ah, yeah. Did it, I guess.
Yeah, perfect.
Thanks, Doc.
Thank you, Dr. Ferris. My name is Ray Tuo. I'm a faculty member in the data science group. I joined this department in 2018. And, now it's my 5th year here. I mainly teach courses like undergraduate part is 414, which is total quality engineering, and 616, analysis of the industrial experiment. So basically those courses are about what we call design and analysis of of experiment from a data science perspective with application to quality improvement. Basically, in those courses, you are going to learn about how to make planning of experiment and how to analyze the data and how to make the right decision to with the goal of making improvement in terms of the product quality. So my research areas including data science for computer simulation, which is a focused problem in of data science on applications of data from computer simulations. So we basically focus on the specific type of data and uncertainty quantification, machine learning, and some general statistical inferences. And here is my my family, my wife and I got married last year, and currently I'm living in North Houston, Conroe. You know the city. Specifically, my research, I can show you some of my previous research. So this one is a computer simulation. Basically, the real project product actually is a fuselage, the aircraft, the body of the aircraft. We are studying how to apply forces to recover the shape of the body. So basically, it's in collaboration with the Boeing company. What we are doing is to remove the defect, remove the deformation of this part. So it's about industrial statistics and also with the help of computer simulations. So basically, what I'm doing is resolving different data science problems in how to use computer simulations in the most efficient way. So computer simulations can be quite good, but it can take a long time to run, and it has unknown parameters you need to adjust. So data science can help you to make those adjustments and can help you to build models which can improve, accelerate the decision making process. So that's what I do. I'm also working on certain theoretical aspects regarding function recovery and related areas. So the inference of the uncertainty, those things. If you are interested in my work, you can reach me out, send me an email, and we can talk. Thank you.
Thanks, Dr. Dr. Moreno, yes, please. Yeah. Get your slides up.
Perfect. Thank you very much, Dr. Harris. Well, I'm excited to see some new faces and some old faces. In the good sense. Really, in the good sense, old friends that are here, so great to see you, Will. I'm Ed Moreno. I'm associate professor here. My focus is operational research, mostly optimization, it's really. I'm the faculty advisor, for ISE student chapter. If you don't know it, it's like the largest in the nation, and it's also probably the most active also. So definitely take a look at it. Lots of great workshops, connections. My hobbies are basketball. I haven't played for a while. Scuba diving, and that's with some whale sharks in close to Saudi Arabia, actually. And then this is all my sets of graduates, except that COVID happened, and then I don't have a picture with this particular one round. And then also because of COVID, I couldn't take like the normal picture, so I went to Disney with my other PhD student, and he had to fight me to get his PhD. So So that was cool. And that's my family, my wife, my girl Nina, and boy Juan Pablo. I have done some research in applied optimization in the energy grid, and I can tell you there are two things why we have electricity: duct tape and prayers. Like, it's crazy the operations that they have. It's just a miracle. It's really a miracle that we have electricity. So that's why we need you to be good at using actually the tools, so that you don't, when you go out there, you don't do empirically stuff like, it seems like this should work. It has worked for 100 years. No, we can do better than that now. So that's my hope, that you'll be able to do that. And then another important hobby is mingling with the Aggie Honor's office. I'm a frequent flyer there, or my students are frequent flyers. So yeah, just if you're in one of my classes, just follow the rules and work with friends. Otherwise, not so much. Okay, so these are some pictures with students. After my exams, I have them at night, and then I invite students to go and play, whatever they want to play. I have done everything: basketball, soccer, badminton, volleyball. I don't know even, I didn't even know it existed, but we played volleyball inside a compound court. I don't have a picture, but also we have done pickleball and soccer. This was this semester. 42 out of 78 students showed up. That's a record for me, percentage-wise, number-wise. So, I also like to have fun, and yeah, that's it really.
Thank you, Moreno.
Excellent.
And I know what you mean. We have lots of old friends here of all ages. So. Yes, our next speaker, thank you, is Dr. Jason Lee. Very excited to greet him as the newest new faculty member here. So, oops, hang on, I got it. Go. Thanks everybody for staying on time. It's amazing. All right, Dr. Lee, thank you.
Thank you everybody for staying here. Yeah. So my name is Jason Lee. So I'm the newest assistant professor in the Department of ISENs. My research focuses on the data science in the application of advanced manufacturing. So I'm currently teaching ISEN 350. So I just finished the last session. So because this is the first semester, this is the only course that I have taught. And my research focuses on data science, the application of advanced manufacturing process, and the IoT-enabled smart and connected system. What I mean by advanced manufacturing process, the examples are the nano manufacturing or 3D manufacturing. For the IoT-enabled smart and connected systems, you can easily imagine the smart manufacturing or smart production systems, or like IoT-enabled like service systems. Basically, my research had raised the engineering knowledge and mathematical model, as well as statistics and machine learning models. And I established a new advanced data science methods. Yeah, here are the brief summary of my previous research. So the left side are about the additive nanosensor manufacturing process, and the right side is about the advanced manufacturing system or IoT-enabled service or IoT-enabled manufacturing and production. The first one was about the inferring the underlying variable based on the data with a significant variation, right? So I established a statistical model to quantify the uncertainty and predict the underlying variable. And the second one is about the modeling the random patterns of the output of the additive nanosensor manufacturing process, right? So I built a probability model for the random patterns, and based on the probability model, I established a statistic that can identify abnormal printed patterns. So because this is using the probability theory, so this method doesn't require a large number of samples to learn the model, and this is a great benefit in terms of usage, right? And this part is about the smart manufacturing. So basically, in the smart manufacturing, you want to identify the quality variance, quality operation with excessive variation. So we have a large number of like machines. So we have a large number of operation, and we don't know where the like quality operation is. So this with the measurements, with the limited measurements, we want to identify the like quality operation. And the last part is about the preventive methods, and I integrate the statistical model and the reinforcement learning or the machine learning method with the reinforcement learning or deep learning method, and to make the right decision in terms of when to do the preventive methods, right? So this is all about myself. So if you are interested in my research, please feel free to contact me. My email will be, you can find it in the faculty. All right. Thank you.
Thank you, Dr. Lee. All right. Yes, all right, great. Well, we almost made it. You have one more presenter, and it's me. So first, right before I begin, I'm also the wrap-up guy. So let me just say just a few more things. So if you're an engineering honors student, make sure you have signed in, QR code there, and also could enter it this way. And this has been recorded. We are going to make a video. We will make it available to those who requested at least. We'll see how we'll work with some people to add a few things to it. And in particular, I'm going to update the schedule because we jumped around just a little bit. So this schedule will be updated. Also, I will have accurate representation of the focus areas of everybody you heard about here. So there's a few details I learned as we were watching. So here's this guy. All right. So I am Tom Ferris. I'm an associate professor. I've been here since 2011. Dr. Moreno was my cohort in crime going through the becoming a real researcher, I suppose, here together. I am a health and human systems focus. I teach 330. I'm currently teaching ISEN 434. And that's been fun to reteach after a while. And I teach graduate courses in the cognitive systems aspects of human factors. Human information processing, probably my favorite course to teach. I'm teaching that right now also. The research I do stems from this, so I'm interested in how information gets into the brain of a human, and so display design, and I'm really interested in unusual displays, ambient displays using multisensory methods. Increasingly, I am doing artistic expressions in that multisensory interface realm, and so I have it blends into my hobbies a little bit, building devices that take some sort of sense about the environment and display it in some colorful way. For example, I also call myself a registered, I'm a lightsmith. I do work for local, like that's for the Nutcracker Ballet. If you go to the Nutcracker Ballet this year, you'll see my illuminated sleigh. That's me. So this is my lovely family. My daughter is 13, and my son, he does pretty well on my midterms as a 15-year-old. He's really bright, so you may see him around here. That's me. That's a little bit about my personality, my personal life. I like to play music, key instruments. I play every week with friends. I build my own instruments. So if you're really interested in something weird, I have a functioning prototype. You really have to come. You have to come to my office hours and ask nicely, and I'll let you play with it. Oh yeah, this is the other cool thing I've been doing this last year. So I've been on sabbatical for a year, and one of the things I did is I could go for a weeks at a time to be a judge at this major event, the ANA Avatar X Prize. Google it, check it out, because it's really, really impressive. There's some pretty cool PR on their website. It is a $10 million prize that goes to the team that builds the avatar that most successfully can do human avatar interactions. So the person controlling this robot in a different part of that building is Dr. Katie Tippy, a former student of mine. And so she and I are both gigging it. I don't know if you can tell from the robot there, but we have these interactions. I'm talking to Katie through Dr. Tippy through the robot, which is really fantastic. And as a judge, I get to then apply my human robot interaction scientific knowledge and say, here's why I think this is a quality interaction versus not. And then $10 million is the prize. So bribable. All right, if you're interested in any of this sorts of topics, please email me. I have regular lab meetings on Fridays. We have one this afternoon. We have a very solid group. Harrison's a longtime member. I've loved working with him and many other people. In general terms, we build displays and interfaces. So what is your ability to build things? I may ask you, hey, do you like to work with microcontrollers? We can talk that stuff, or we also have existing things in the lab, that you might learn the special way to work with them, our vibrotactile interfaces, for example. We're interested in wearables and building things that are interfaces that can be on my body for various sorts of activities. If you like to do things or would like a chance to learn something like app development for a wearable, let me know. There's always those sorts of things we're interested in. We have driving simulator and flight simulator in my lab. I should say really our driving simulator is the main thing right now, but it's a nice environment for kind of, okay, I can see how I can put the code in to change aspects of it. You can see based on our existing work, we have quite a lot to build off of here. And I'm also interested in physiological signals, sensing what's happening with the humans and inferring things like stress, workload, emotional state, and how that might impact how humans behave. That's me. Thank you very much. That's my email address. And I think we're all done. And we got to clear out of here because I know there's a faculty meeting in this room. So thanks, everybody. Wow. Enjoy the rest of your day. I hope it's been enjoyable and successful when you contact faculty and see what you can do next. All right. Thanks, everyone.